Hi. So I'm going to be doing the instant ice assignment tonight. And I just got a water bottle out of the freezer, and there is still some water moving around, so it's not completely frozen. Um, so basically, what I'm supposed to do is, since you can still see the water moving around, I'm supposed to tap it, and it's supposed to freeze. So there is some frozen water inside the bottle. I don't know if that's from my freezer or not, but I do have another bottle in there so that we can try it again later. So the question basically is, why does water freeze instantly when you hit the water bottle just out of the freezer? So there's a good explanation to this, and it's kind of cool and interesting. So the liquid in the bottle is super cold. The supercooling means that the temperature of the liquid is below the normal freezing point, but the liquid has still not turned into a solid yet. So this is because it needs something to kickstart the freezing process and encourage a small number of the liquid molecules to get in together in a regular arrangement as they do in a crystal, rather than moving around independently like they would in a liquid. So rather than it being a non-cold bottle of water and just a regular bottle of water, one that hasn't been in the freezer at all. So this whole process that I just have been talking about is called nucleation. Nucleation encourages the molecules in the liquid to form a crystal-like nucleus onto which others then can latch onto. So the kickstart, or the initial reaction, can be given by like a piece of dust onto the bottle, a rough spot on the surface of the container, or a shock wave generated when you hit the bottle. So when I hit the bottle, that's what kind of caused the freezing to take place. And that's kind of what the nucleation, that's kind of how it was kick-started when I just got the bottle out of the freezer. So once nucleation occurs, the water clumps together and other molecules can latch onto the nucleus. So once I hit the bottle, other molecules could latch on and freeze to other stuff inside the bottle. So now there's, it actually got a lot more ice in it when I just shook it like that. It like expanded and the ice kind of climbed to the top. It kind of froze a little bit more when I hit it like that. So that whole process is called nucleation. So to supercool a water bottle, you lower its temperature below the normal equilibrium freezing point by removing heat. So I put a normal room temperature water bottle into the freezer, and I removed the heat from it to lower the water bottle's temperature below the normal equilibrium, which made it that kind of cold, kind of frozen texture, which is the supercooling. So the reason that it wouldn't occur, so if it didn't work as properly as I thought, the reason that is because obviously some freezers do not work the same, because freezers use these motors typically, which cause vibration. So if the water is vibrating, then that could cause it to not cause that supercooling. And then when I go to hit it, it won't freeze. So when you tap the bottle, like I said, it may disrupt the seed crystals by freezing, which is what I kind of explained. Another reason is also because the freezer may have been too cold. So maybe I left the bottle in too long, or it just kind of cooled the bottle too fast. So like I said before, supercooling was removing the heat. Heat flows from hotter objects to colder objects. So that's why I had to place the water bottle in the freezer, so it was like in contact with something colder. I will grab another bottle out of the freezer just to kind of see, because this one was a little bit more frozen than the others. I want to see if the other bottle works. So let me grab that very quickly and let's see if that works a little bit better. So I have this one. I'm not sure if it's going to work. As you can see, this one's kind of more liquidy in form. So I'm going to go to hit it. Okay, so actually here you can see it totally worked. I'm super surprised that this worked. So I hit it and it froze, which was pretty cool actually. I didn't think it was going to work. So in this case, the experiment worked for me, and this is how we did an instant ice. And I hope you enjoyed. Thank you.